Hello everyone, my name is Jorge Isaac, and in this video I'll explain my BCD to 7-segment display project made in Quartus Prime Lite using the DE10 Lite FPGA board. So let's go. BCD to 7-segment display is a digital circuit that converts binary code decimal value into signal that can activate the correct segments on a 7-segment display. Basically, it allows us to show numbers from 0 to 9 using LEDs on the display. So in this project uses a 4-bit input called BCD and enable signal and a 7-bit output called seg anode, which controls the 7 segments A to G. So let's go to the PhD. We are in the PhD already. The main interface is called BCD to 7-segment. Inside we process a block that checks the BCD input and the enable signal. If enable equals 1, the circuit checks the binary input using a case statement. Each 4-bit value corresponds to a number from 0 to 9. For example, when BCD is 0, 0, 0, 0, 0, 0, 0, the display shows 0. When BCD is 0, 0, 0, 1, the display shows 1, and so on up to 9. If enabled is 0, the output is 0, 0, 0, 0, 0, which means all segments are off. At the end, the code inverts the output with seg analog, not seg, because the display works with active low signals. So let's go to the PhD. In the test bench, we simulate how the circuit behaves. We declare all the signals BCD enable and seg anode. We connect them to the main entity using the port map. After that, we test out the possible values from 0 to 15. For each test, we first set enable to 0 to make sure the display stays off, and enable 1 to check that the number appears. Each test lasts 10 nanoseconds, and the total of the simulation time is about 320 nanoseconds. So after we created our RTL simulation, here we have the BCD, enable and seg anode. Here you can see the numbers, the binary numbers 0, 1, 2, 3, 4, 5, 6, 7, and if the enable is 0, it shows the display as off, like it's not turned on because it doesn't show nothing. So if enable is 1, so that will count the numbers that we put in our inputs. So for example, for 0, for BCD in 0, enable in 1, we have the number 0. For BCD 1, we have enable 1, and then we have 1 in the 7-segment display. And for each case we have the respective number. So let's go to the pin planner and upload to the board. So here we are, as we as we saw in the menu. Each segment has a pin, and for segment 0 is C17, for segment 1 D17, for segment 2 E16, for segment 3 E16, C15, E15, C14, and for enable we put the display the switch 0 to it's switch 4 for enable, and for the rest switch 0, switch 1, switch 2, and switch 3. So we upload it to the board using the programmer and clicking on start, and when it's 100% uploaded we can see it on the board. So let's go to the FPGA. So here we are on the FPGA, and this is our enable. If we turn off, the display does not show nothing, so it doesn't matter if any input is on. But if we enable the enable you can see that the numbers are shown in the display. So for 1 we have 1, for 2 we have 2, for 3 we have 3, for 4 5 5, 6 6, 7 7, 8 8, 9 9, and for the rest of the numbers we have a U that it's invalid. So that's all, and see you in the next FPGA program.